Example number 3. Here again, we have an expression that's exactly 1 degree greater than another expression making up our entire integral. So what we're going to do is we're going to let this expression that's 1 degree greater be equal to u, if I knew how to write. Let u be equal to x cubed minus 2. And now we take the derivative of each side. So this is 1 du on the left, and on the right we get 3x squared dx. Here again, we have a situation where we don't want this 3 to be our coefficient of x squared dx. So we get rid of it by dividing both sides of this equation by 3. And again, this means the same as 1/3 times du equaling x squared dx. So this is very similar to our previous example. We now have what we want in this equation based on what we had in our original integral. All right, so let's rewrite this thing. So the 1/3 again, if you have to do this, the 1/3 gets placed in front of the integral symbol. And now what we have is the du is exactly the same as this. So we write du on top in the numerator. Now we're going to be dividing this thing by what? Well, the square root of u. All right, so if this doesn't, look nice to you, which it really doesn't look nice to me either, I would rewrite it. Again, if you have something in radical form, I highly recommend you rewrite it in exponential form. So what I mean by that is, what I mean is the square root of u in the denominator is the same as u to the 1/2 in the denominator, which is the same as u to the negative 1/2 in the numerator, still with respect to u. Okay, now we're finally ready to go through our motions. So let's take the integral of u to the negative 1/2. All right, the 1/3 constant multiple rule comes down here. And let's look at the integral of u to the negative 1/2. So we're going to add 1 to negative 1/2. Negative 1/2 plus 1 is 1/2. Then we divide by that new exponent. And again, because it's indefinite, we do plus c. Okay, a couple things here to finish this up. The first thing, excuse me, we're dividing by 1/2. When you divide by 1/2, that is exactly the same as multiplying by 2. So this really means 2 times 1/3 or 2/3. This part, u to the 1/2, means the same as the square root of u. Okay, but remember, we have to use substitution one more time. So what's u equal to? U is equal to x cubed minus 2. So that's what we put underneath the radical, x cubed minus 2. Then we put our plus c, and we're finished with the third example. In example number 4, we're looking at a new type of integral, one in which is base e to the power of something with respect to x. So in this situation, what you want to do is you want to let u be equal to whatever that exponent is. And after you've done that, you're going to take the derivative of both sides, giving you du equaling negative 0.025 dx. Because you don't have a negative 0.025 right here in front of this e in your original integral, you want to divide both sides by that value to get dx alone, because dx is alone in our original integral. So what do we do with this? Well, here's what we do with this. Boy, that's really sloppy, that brace there. Oh well. What we do is this. Whatever is going on the left-hand side of this equation, if there's a numerical value here that's a part of this du, you're going to put that numerical value in front of the integral symbol. And then what you're going to do is rewrite the given integral right here, rewrite this in terms of u. So does it make sense that you have the integral of e to the u, which is this, with respect to u? Everything has been taken care of now in terms of making the appropriate substitution. All right, so let's go ahead and finish the job. So this number stays the same. And then let's evaluate this integral. So this integral would be, well, what's the integral of e to the u? It's just e to the u. And then we put our plus c. Now, we don't want to leave it in terms of u, so we do this. Times e to the, what's u? Oh, there is u, right there. There it is. So let's write that down. And now we're finished. Well, I mean, if you really wanted to, I guess you could divide this, 1 divided by this negative 0.025. That's the same as negative 40, by the way. So if you really wanted to, you could write this as negative 40 e to the negative 0.025x plus c. But this is fine as well. I'll accept this.